The solar system has a new member. Astronomers have recently discovered a previously unknown dwarf planet in the outer regions of our homeworld. Named 2017 of 201, the celestial body immediately attracted attention with its highly unusual orbit. Not only does this tranquil world take a whopping 25,000 years to orbit the Sun, it also moves in an eccentric orbit that extends from just beyond Pluto to 1,600 times the distance between the Sun and Earth. But that's not all. This object, with its peculiar orientation, actually provides valuable information about a very special missing case and could finally bring us a decisive step closer to the mysterious Planet 9. So, be sure to stay tuned until the end if you want to know what this exciting discovery is all about and what it reveals about the hidden member of our planetary system. In our broad perception, the solar system often ends with Neptune. And although it's true that the mighty ice giant is the eighth and outermost known member of our planetary system, this does not mean that it also marks the boundary of our homeworld. On the contrary, far beyond the orbit of the planets lies the Oort cloud, a hypothetical region believed to be the origin of long-period comets. Not quite as far away, but still not exactly around the corner. At a distance of about 30 astronomical units, is the Kuiper Belt, an area that also belongs to the solar system. And just to remind you, the length of an astronomical unit is equal to the average distance between the Earth and the Sun, around 150 million kilometers. And similar to the Oort cloud, the Kuiper Belt is also considered the home of many comets and a reservoir of countless chunks of rock. In fact, it took until the early 1990s before the actual existence of this ring was proven, and it still holds many unsolved mysteries for experts. The bottom line is that we only know a fraction of these so-called transneon objects. And yet, astronomers have already noticed a striking pattern. According to this pattern, previous investigations have shown that some of the celestial bodies there prefer to congregate in a very specific area of the Kuiper Belt. The reasons behind this pattern have not yet been conclusively clarified, but some researchers conclude that the observed distribution is due to the presence of a full-fledged planet about the size of Neptune. The extent to which the ominous Planet 9 is real is hotly debated among experts, but what is undisputed is the fact that scientists have now made a spectacular discovery in the outer solar system that could have a significant impact on the search for planets. We owe this discovery to the team led by Si-Hao Xiong from the Institute for Advanced Studies in Princeton. The experts had examined the data from a sky survey conducted with a dark energy camera at the Blanco telescope in Chile in detail and identified a telltale point of light that had gradually changed its position between 2014 and 2018. The experts stated that it was obvious that these points of light must have come from a moving object traveling in an extremely wide and eccentric orbit. This initial assumption was finally confirmed when the object also appeared in archive images from a second sky survey conducted with a Canada-France-Hawaii telescope. And from then on, it was clear that there was a large trans-Neptunian object out there that no astronomer had ever heard of before.
Pluto's extraordinary cousin.
However, the actual discovery was not even the most exciting part of the story. The celestial body Kristen 2017 of 2011 is also extremely unusual for two reasons. Firstly, it's astonishingly large, measuring around 700 kilometers across. As a result, it's not only the second largest known object in this remote area of the solar system, but also, thanks to its uniform brightness, a dwarf planet. Researchers say that 2017 of 2011 meets the criteria for this designation because it has enough mass to become spherical due to its own gravity. The second thing that makes this tranquil world so extraordinary is its
extreme orbit.
While the point in its orbit furthest from the Sun is more than 1,600 times further away than Earth, the point closest to the Sun is around 44.5 astronomical units away, roughly in the vicinity of Pluto's orbit. Translated into cosmic reality, this means that the dwarf planet takes around 25,000 years to complete one full orbit around the Sun. However, this also means that the researchers not only had the right instinct, but also good timing. In fact, the object spends less than 1% of its time in regions that are visible to our telescopes. The dwarf planet only came into our sights because it passed its closest point to the Sun and Earth relatively recently. More precisely, this was in November 1930. Excitingly, the same year that a certain celestial body called Pluto was discovered. Since then, however, not only have several decades passed, but also countless kilom. 2017 of 2011 has been moving continuously away from us ever since and is currently around 90.5 astronomical units away. This makes it one of the most distant objects in the solar system that can still be observed in visible light. And while its visibility will naturally decline rapidly in the future, the discovery of the dwarf planet provides further exciting clues in a much larger context. On the one hand, experts assume that there could be at least 100 celestial bodies of comparable size and with similarly extreme orbits in the Kuiper Belt, but since they are currently too far away, we are unable to identify them. Secondly, and even more exciting, the dwarf planet also provides valuable information about the hypothetical Planet 9. Is there an unknown planet out there after all? As briefly mentioned earlier, the evidence for the existence of a hidden planet in the solar system is indirect. More specifically, it refers to the conspicuous accumulation of objects with similarly aligned eccentric orbits in the Kuiper Belt. The corresponding orbits are often in the range of 60 degrees. But 2017 of 201 breaks this pattern. The orientation of its perihelion, or in other words, its closest point to the Sun is 306 degrees, which differs strikingly from the orientation of other extreme trans-Neptunian objects. And this raises a fundamental question about the dwarf planet. Are its characteristics even compatible with the Planet 9 hypothesis? If there really is a Neptunized 9th planet out there, why doesn't its gravity also influence the orbit of 2017 of 2011? That's exactly what the team of first discoverers led by Si-Hao Chong wanted to know. And so, the experts used a model to reconstruct the possible interaction between Planet 9 and its dwarf counterpart. The bottom line was that without the existence of the planetary phantom, 2017 of 2011 would remain in a stable orbit for at least a billion years. However, as soon as Planet 9 comes into play, gravitational interactions change the dwarf planet's orbit so that it comes too close to Neptune. This is a constellation that inevitably ends in the demise of the small celestial body as it will be catapulted out of the solar system after about 100,000 years. It can therefore be concluded that the existence of 2017 is difficult to reconcile with the Planet 9 hypothesis. Scientists have concluded that the existence of a previously undiscovered planet is therefore becoming less likely. But less likely does not mean impossible. And if Planet 9 really does exist, we now even know quite precisely where the chances of finding it are greatest. At least that was the conclusion reached by Mike Brown and Konstantin Batigan from the California Institute of Technology when they ran through a number of different scenarios and model simulations. More specifically, the astronomers assumed different masses and sizes for Planet 9 and took into account other possible factors in addition to the gravitational effects of the planets in order to determine the most likely orbit. The goal was to find the orbit that best explained the movements of 11 trans-Neptunian objects with wide orbits and orbital deviations. This ultimately resulted in a sky map that narrowed down the planetary search area more precisely than ever before. If the hypothetical planet is similar to Neptune and weighs a good 6 Earth masses, its orbit would have a semi-major axis of 380 astronomical units. Against this backdrop, it could oscillate between a point closest to the Sun at 300 astronomical units and a point furthest from the Sun at 450 astronomical units on its journey through space. If, on the other hand, Planet 9 only weighs 2.22 Earth masses, it could even approach the Sun at a distance of 85 astronomical units. Furthermore, the data showed that the planet's orbit is inclined by about 16 degrees to the main plane of the solar system. But where exactly is Planet 9 actually located at the moment? Well, assuming that it actually exists, experts are unfortunately unable to answer this question with any certainty. However, there is at least a suspicion that the celestial body is currently traveling near its furthest point from the Sun. Whether and when Planet 9 will be found depends not only on its distance, but also on its brightness. Since it orbits so far out and moves very slowly against the starry background, it is very difficult to spot it among the countless points of light in the cosmos. But if Planet 9 is particularly bright, and that's the exciting part, it could even be hiding in images from previous sky surveys. And in fact, each of us can help add a new entry to the list of our planetary system. Since 2017, a citizen science project has been underway in which volunteers can search previous survey images for telltale traces. And now you can search for telltale traces of the subscribe button under our video. Just click the thumbnail and subscribe now to never miss a new post from us. We'll see you soon.